Good day everyone, we are Group 3 from 10G.
Today I am going to talk about EM radiation around us. What is electromagnetic radiation?
Electromagnetic radiation is a form of energy that is all around us and takes many forms such as radio waves, microwaves, X-rays, and gamma rays. Sunlight is also a form of electromagnetic energy, but visible light is a small portion of electromagnetic spectrum which contains a broad range of electromagnetic waves.
Electromagnetic theory. Electromagnetic theory. Electricity and magnetism were once thought to be separate forces. However, in 1873, Scottish physicist James Clerk Maxwell developed a unified theory of electromagnetism. The study of electromagnetism deals with how electrically charged particles interact with each other and with magnetic fields. There are four main electromagnetic interactions. 1. The force of attraction or repulsion between electric charge is inversely proportional to the square of the distance between them. 2. Magnetic poles come in pairs that attract and repel each other much as electric charges do. 3. An electric current in a wire produces a magnetic field whose direction depends on the direction of the current. 4. A moving electric field produces a magnetic field and vice versa.
Waves and fields. Electromagnetic radiation is created when a particle, such as an electron, is accelerated by an electric field causing it to move. The movement produces oscillating electrics and magnetic fields which travel at the right angle to each other in the bundle of light energy called a photon. Photon travels in a harmonic wave the fastest speed possible in the universe, 186,282 miles per second, 299,792,458 meters per second, in a vacuum, also known as the speed of light. The waves have certain characteristics given as frequency, wavelength, or energy.
Maxwell also developed a set of formulas called Maxwell's equations to describe these phenomena. A wavelength is the distance between two positive peaks of a wave. This distance is given in meters m or fractions thereof. Frequency is the number of waves that form in a given length of time. It is usually measured as the number of wave cycles per second, or hertz, Hz. A short wavelength means that the frequency will be higher because one cycle can pass in a shorter amount of time. According to the University of Wisconsin, similarly, a longer wavelength has a lower frequency because each cycle takes longer to complete.
The electromagnetic spectrum. Electromagnetic radiation, an enormous range of wavelengths and frequencies. This range is known as the electromagnetic spectrum. The electromagnetic spectrum is generally divided into 7 regions in order of decreasing wavelength and increasing energy and frequency. The common designation are radio waves, microwaves, infrared, visible lights, ultraviolet, X-rays, and gamma rays. Typically, lower energy radiation such as radio waves is expressed as frequency, microwaves, infrared, visible lights, and UV light are usually expressed as wavelength. And the higher energy radiation such as X-rays and gamma rays is expressed in terms of energy per photon.
Radio waves. Radio waves are the lowest range of the EM spectrum with frequencies of up to about 13 billion Hz or 13 GHz and wavelength greater than about 10 mm (0.4 inches). Radio is used primarily for communication including voice data and entertainment media.
Microwaves. Microwaves fall in the range of electromagnetic spectrum between radio and IR. They have frequencies from about 3 GHz up to about 30 trillion Hz or 30 terahertz, and wavelength about 10 or 0.4 inches to micrometers or 0.004 inches. Microwaves are used for high bandwidth communication. Radar as a heat source of microwave ovens industrial applications.
Infrared. Infrared is in the range of the EM spectrum between microwaves and visible light. IR has frequencies from about 30 terahertz up to about 400 terahertz and wavelengths of about 100 micrometers (0.004 inches) to 740 nanometers or 0.00003 inches. IR light is invisible to human eyes, but we can feel it. It has heat if the intensity is sufficient.
Visible light. Visible light is found in the middle of electromagnetic spectrum between IR and UV. It has frequency about 400 terahertz and to 800 terahertz and wavelength of about 740 nanometers or 0.0003 inches to 380 nanometers or 0.00015 inches. More generally, visible light is defined as the wavelengths that are visible to most human eyes.
Ultraviolet. Ultraviolet light is in the range of the EM spectrum between visible light and X-rays. It has frequencies of about 8 times 1014 to 3 times 1015 Hz and wavelengths of about 380 nanometers (0.00015 inches) to about 10 nanometers (0.0000004 inches). UV light is a component of sunlight. However, it is visible to the human eye. It has numerous medical and industrial applications, but it can damage living tissue.
X-rays. X-rays are roughly classified into two types: soft X-rays and hard X-rays. Soft X-rays comprise the range of electromagnetic spectrum between UV and gamma rays. Soft X-rays have frequency of about 3 times 116 to about 118 Hz and wavelengths of about 10 nanometer or 4 times 10⁻⁷ inches to about 100 picometers or 4 times 10⁻⁸ inches, 8 inches. Hard X-rays occupy the same region of the electromagnetic spectrum as gamma rays. The only difference between them is their source. X-rays are produced by accelerating electrons while gamma rays are produced by atomic nuclei.
Gamma rays. Gamma rays are in the range of the spectrum above soft X-rays. Gamma rays have frequencies greater than about 1018 Hz and wavelengths of less than 100 pm, 4 times 10⁻⁹ inches. Gamma radiation causes damage to living tissue, which is useful for killing cancer cells when applied in carefully measured doses to small regions. Uncontrolled exposure thought is extremely dangerous to humans. Question. Assuming that you are a medical doctor and someone approaches you to have a medical consultation. The patient is complaining of comfort, has no fever and no difficulty in breathing. The patient is suspected that he may have a pneumonia or worse, COVID-19. Will you recommend that the patient to undergo chest X-ray? Define your answer.
Yes, of course. When a patient undergo a chest X-ray, I can allow to see his lungs, heart, and blood vessels to help determine if he or she have a pneumonia. This exam will also help to determine if she have any complication related to pneumonia, such as abscesses. So it's really important to seek immediately medical attention if you are really